Hi, and welcome to Engineer's Mindset. Today we'll continue with a series on three dimension with a problem which says three cables are used to tether a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing the tension in cable AB is 259 newtons. Alright, so we have a balloon, and we have three cables from B to A, from A to D, from A to C. These cables are used to tether this balloon at point A. Now the question is saying that there is a vertical force at P, okay, and the question is asking us to determine that vertical force at point P. Alright, so this is a little bit different from the first question we solved in this series. In the first question, it was just a one cable, but in this case, we're having a three cable. Alright, so like I always say, whenever we have a problem in three dimension or in applied mechanics, we have to always plot out the free body diagram. Alright, so in order to plot the free body diagram, we are going to label this side to be our X. So this is positive S. So it means first component pointing towards the direction is positive S. It means first component pointing backwards is going to be negative S. So this is going to be our negative S. Okay, so these are positive Z. Okay, this is Z component. Okay, so this is positive. So it means if it points backwards, it's going to be negative. So these are negative Z. Okay, similarly, vertically upwards is positive. So these are positive Y. It means downwards is going to be negative, okay, minus Y. And remember that our X is usually I in vectors. So this is minus I, backwards is minus I. Okay, if this is K, Z is K. In vectors, backwards is minus K. Y is J, and downwards is minus J. Alright, so we'll use that to plot our free body diagram. So, free body diagram. Alright, so we have the vertical line. So we introduce the vertical line, which is this. Oh, okay. Sorry. Alright, so we have the Z direction. Okay, so we'll have this to be the Z direction. Okay, something like this. Alright, so this is Z. So which is actually plus K plus C. So it means backwards is going to be minus C minus K. Okay, from the diagram we have, okay, these are X pointing towards this direction. So we'll have our X towards here. So these are positive S, which also positive I. Okay, so backwards we have our negative S. Okay, we have our negative S backwards. Okay, so this minus X, also minus I in vectors. Alright, so from point A we have a cable channel to point B. So from point A we'll have a cable to point A. So this is point A, and of course we'll have a cable. This is point B, this is point A. Alright, so there's a tension is tied at point B. Alright, so we'll have a tension in this cable, tension in cable A, B. Similarly, from point A there's a tension cable down to point D. Alright, so we indicate that there's a tension down to point D. Okay, hooked at this point. So we'll have this point A, this point D. So we'll have a cable, a tension in cable AD. Similarly, from point A there's also a tension cable connecting at point C, or tied at point C. Alright, so from point A we'll have a tension here at point C, which is something like this. Okay, so we'll have this. Alright, so this is point C. So we'll have a tension in this cable. That's tension in cable AC. Alright, so we have three cables, 1, 2, 3. Okay, we have to now determine their positions. Okay, so in this case we'll have 4.2 distance from here to this other cable. So the distance from Z to this cable is 4.2. So we indicate it the way it is, 4.2. Alright, so we'll have this 4.2. Okay, we also have this distance 2.2 meters from Z to C. So we'll have distance from here to this point Okay, that's 2.2 meters. 2.2 meters. Also, we have distance from C, from X to point C, 4.2 meters. So we indicate that from X to point C, okay, we have this 4.2 meters. Okay, from point D to point X, from X to point D is 3.30. So we'll have distance from this point. Okay, let this signify point D. Distance from X to D is 3.30 or 3.3 meters. Then we have the height from the origin to the point A. The height is 5.6. So this is the origin, okay, and this is point A. So from the origin to point A, we'll have a height of 5.60 meters, okay. And the question says determine the vertical force P exerted by the boat at A. So which means that at point A we have a force P, and that force is vertical. So we cannot assume that the force could be pointing upwards or it could be pointing downwards. Any one, you're correct. If it's pointing upwards, like I told you, if you choose upward direction and you have negative, it only means that the direction you assumed was wrong, but the answer will always be correct. Okay, so we cannot assume it to be pointing upwards. Since it's vertical, let's assume that we'll have a force P pointing upwards. So this is force P pointing upwards. So these are Y, okay, these are X, okay, and Y is always J. Remember, going upwards is J, downwards is minus J. Okay, so this is the free body diagram of the system. So we now relate. There's a tension in cable A to B, there's a tension in cable A to D, there's a tension in cable A to C. So we'll start by the individual tension. All right, so recall tension in cable AB from what we did in our first, when we were doing analysis, when we started the analysis of 3-dimension. The tension in cable AB is simply magnitude of tension in AB times the unit vectors in AB. And we know that unit vector in AB, which is lambda AB, in terms of position, is simply RAB or RAB all over magnitude of RAB. Okay, and this is simply what RB minus RA, okay, all over RBA magnitude. Okay, so having this in mind, we'll now find the position vector for cable AB. So recall from the earlier analysis, we said move from the origin and locate all the points. So we'll move from the origin to locate all the points. All right, so at the origin, RO equal to 0 at origin. At origin, okay, so the position vector at origin is 0, earlier stated. Now we move from O to locate point A. Point A is vertically upward, so RA is equal to, from the origin you move upwards. Now you're moving from the origin to locate point A. Point A is here, and the distance to point A is simply this height, which is 5.6. Distance of point A is simply the height, which is 5.6. And since you're moving upwards, you're moving vertically upwards in the positive J direction. So it means RA is 5.6 positive J. Okay, let's locate point B. Now this is our X positive, so if you're moving backwards it's negative, and point B happens to be backwards. So I'm moving from this point to this point, covering this distance of 4.2 to get to point B. So since I'm covering 4.2 and I'm moving backwards, is negative and X is I, so it means RB is minus 4.2 I, minus because we're moving backward to locate point B. Okay, we also have point D. Okay, so point D from the origin, this is positive to the Z axis, which is K. So point D happens to be what? Backwards. I have to move from this point, from the origin, to locate point D, moving backwards. So as I'm moving backwards, I've covered this distance 3.30, but moving towards negative K direction. So this is RD is now equal to minus 3.3 in the K axis. Okay, another point C, RC. So we'll locate RC, point C. So point C, notice that point C happens to be at the middle, at the midpoint. So I have to take different channels to get to point C. First, I have to move from the origin, I have to move from the origin through this distance. This distance from here to here is this distance from here to here. Okay, so then I'll move from this point, that's from point Z, now to locate point C, covering this distance, which is 2.2. Or I can also move from here to this point, which is covering this distance 2.2. Move from here to this point, covering this distance 2.2 in the x-axis. Then move from the S, covering the distance 4.2 in the z-axis. So ROC actually has two positions. Okay, it's situated at the middle, at the midpoint. So if I move from the origin first to this point, I've covered this distance towards the x, and it's positive because it's moving towards the positive x-axis. So that's positive I, covering a distance of what? 2.2. Okay, so that means I have 2.2 I. Okay, but from x, I will now move back towards this point to locate point C, moving back, covering the distance of what? 4.2. And this happens to be what? Positive direction of Z. This happens to be the positive direction of Z from the origin. This is Z positive. So moving in this direction, I'm moving positive to Z. So I have this to be plus. And I've covered a distance of 4.2. So plus 4.2. Okay. Alright, so those are all the positions. So we start with tension in cable AB. Alright, tension, starting with tension in cable AB. In cable AB. Okay, so tension in cable AB happens to be magnitude of tension in AB times unit vectors in AB. So we'll now find unit vectors in AB. Unit vectors in AB, okay, we already know this to be position vector in AB all over magnitude of the position vector in AB. Okay, so position vector in AB, ROAB, I've told you, is equal to ROB, the final position always minus the initial position. So ROB minus ROA. Okay, so this is equal to ROB. We obtain ROB to be minus 4.2 I. So ROB is minus 4.2 I minus ROA. ROA stands for 5.6 J. So ROA is 5.6 J minus 5.6 J. Okay. Okay, so RAB, the position between A and B is simply minus 4.2 I minus 5.6 J. After that, you obtain the magnitude of RAB. So magnitude of RAB is simply the square root of the square of the individual term. So we have minus 4.2 square, okay, plus minus 5.6 square. Okay, I'll give us the magnitude. So RAB magnitude equal to square root 4.2 square, 17.64, okay, plus 5.6 square, that's 31.36. So we'll add up RAB magnitude equals square root. So we'll add up, and that gives us 49, and that implies a magnitude RAB square root of 49 is simply 7. So we'll have that to be 7. Alright, so after that, the unit vector lambda AB is now we said is position vector all over magnitude. So position is what? Position vector is minus 4.2 I minus 5.6 J. So minus 4.2 I minus 5.6 J all over magnitude. Magnitude is 7. Okay, so this is equal to minus 4.2 I divided by 7 minus 5.6 J divided by 7. So lambda AB is now equal to, so we evaluate this, minus 4.2 divided by 7. That gives us minus 0.6 I. Okay, minus 5.6 divided by 7. That's minus 0.8 J. Alright, so that gives us the unit vectors. Alright, so recall we said tension in cable AB, the position vector of the tension in cable AB is simply magnitude of tension in AB times unit vectors in cable AB. Okay, so that simply implies but, okay, but recall what tension in cable AB was given. I think it was given. Question says knowing that the tension in cable AB is 259 newtons. So tension in cable AB was given as 259. So TAB is equal to 259. That's the magnitude of the tension, which is this. So that simply implies now that the position vector of the tension in cable AB is simply equal to magnitude, which is 259 159 multiplied by unit vector in cable AB, and unit vector in cable AB is simply minus 0.6i minus 0.8j. So we can now evaluate and expand this. Okay, that implies that tension in cable AB is equal to 259 multiplied by 0.6. We have so minus 155.4i, okay, minus 259 multiplied 0.8, sorry. Okay, that gives us 207.2.2g. So you can call this equation 1. So we are done with cable AB. We now analyze cable tension in cable. Okay, let's go with AC, tension in cable AC. Similarly, position vector of the tension in cable AC is the magnitude of tension in AC times unit vectors in cable AC. Okay, so unit vectors in cable AC, of course, is the position between cable AC all over magnitude of the position vector in cable AC. Okay, that's all. So all we need to do is now find out position vector between cable AC. Now, position vector in cable AC, ROAC, is simply what? Final minus initial. So it's ROC minus ROA. So we'll have this. So ROAC is now equal to, let's obtain ROC from, ROC was obtained to be, okay, 2.2i plus 4.2k. So ROC is 2.2i plus 4.2k, okay, minus ROA. ROA is still 5.6j, so minus 5.6j. Alright, so this is position vector between ROAC, okay, between A and C. Alright, so having this magnitude of position vector ROAC, magnitude is equal to the square root of the square sum of the square of the individual terms. So we'll have 2.2 square, okay, plus 4.2 square, okay, plus minus 5.6 square. All right, so we square the individual terms, okay, and take their square root. So magnitude ROAC is equal to square root, okay, let's obtain 2.2 square is 4.84, okay, plus 4.2 square, that's 17.64, plus 5.6 square, that's 31.36. All right, so we'll add them up. ROAC magnitude equals square root, add them up, that's 53.84. So find the square root of 53.84. That gives us 7.34. Okay, 7.34. Okay, meters. So that's our magnitude of the position vector. So we'll now find the unit vectors. Okay, lambda AC. Of course, we said its position ROAC all over magnitude ROAC. Okay, and this is equal to the position vector is simply position vector is simply this 2.2i plus 4.2k minus 5.6j. So we'll have 2.2i, let's rewrite it, minus 5.6j plus 4.2k, okay, divide by magnitude. Magnitude is 7.34, okay, 7.34. all right, so it means that unit vectors in cable AC is simply 2.2i divide 7.34 minus 5.6j divide 7.34 plus 2.2k divide 7.34. So let's evaluate and see. Lambda AC equals 2.2 goes into 7.3. That's approximately 0.3i minus 5.6 divided. Okay, so this gives us 0.76 j plus 2.2 goes into 7.34. Sorry, please, this is 4.2k. Okay, sorry, 4.2k. So 4.2 goes into 7.34. Okay, that's 0.57. Okay, so this is a unit vector. So that implies tension in cable AC, position vector of the tension is simply magnitude of the tension in AC times unit vector in cable AC, and magnitude was not given to us, so it means that position vector of tension in cable AC is simply TAC, tension in cable AC, multiplied by the unit vectors, which is 0.3I minus 0.76J plus 0.57K. All right. I think we should expand the bracket. Yes, let's expand the bracket. So we have tension in cable AC, position vector becomes 0.3, goes into this, so this is 0.3 tension in cable ACI minus 0.76 tension in cable ACJ, okay, plus 0.57 tension in cable ACK. So let's call this equation 2. Okay, so we'll move to tension in cable. We've done AB, AC, AD, cable AD. All right. Tension in cable AD. Okay, TAD also. Position vector of those tension is simply tension in cable AD magnitude times unit vectors AD. Okay, of course. All right. So the unit vectors in AD also is position vector in AD divided by magnitude of the position vector in AD. Okay, so this is simply RD minus RA, okay, all over RAD magnitude. All right, so let's obtain RD minus RA. So RAD position vector is equal to, okay, RD minus RA. All right, so RD is minus 3.3K, RA is minus 5.6J. all right, so RD minus RA, RD is minus 3.3K minus RA is 5.6 J. So let's write it. So J comes before K. All right, so that means RAB position is simply minus 5.6 J minus 3.3 K. Okay, magnitude of RAD is simply the square of, take the square root, minus 5.6 square plus minus 3.3 square. All right, so RAD magnitude is equal to square root 5.6 square. All right, that's 31.56 plus 3.3 is 10.89. okay, so RAD magnitude equals, okay, sum them up, that's 42.45. all right, so we'll obtain the square root of 42.45. that gives us approximately 5.52 meters, and therefore unit vectors in cable AD is position vector, which is minus 5.6 J minus 3.3 K divided by magnitude, which is 5.52. okay, so this simply implies this is minus 5.6 J divides 5.52 minus 3.3 K divides 5.52. all right, so lambda AD is now equal to minus 5.52, minus 5.6 divided 5.52. all right, guys, there's a little bit error upwards. Turns out 5.6 square plus 3.3 square is actually 42.25 and not 45, please. It's 42.25, and the square root of 42.25, square root of 42.25 is actually 6 points. It turns out it's 6 points. It turns out it's 6.5. so please, it's 6.5, guys. It was just a slight error, so it's 6.5. so it means position vector divides 6.5. okay, you can cancel this 6.5. all right, so this is 6.5 and this is 6.5. all right, sorry for that error. all right, so we'll go with 5.6 divided 6.5. that gives us minus 0.86 J minus 3.3 divides 6.5 is minus 0.51 K. so we'll have this to be the unit vectors. Therefore, okay, so position vector of tension in cable AD, simply magnitude of tension in cable AD times the unit vectors of tension in cable AD. Okay, Okay, so the position vector of the tension in cable AD is now equal to, of course, the magnitude is not given, so we'll put it down. Tension in cable AD not given into unit vector, so it's minus 0.86 J minus 0.51 K. Okay, so we can expand this. If we do that, tension in cable AD, okay, position vector is equal to, so we expand the bracket, we have minus 0.86 TADJ. Okay, so we have minus 0.86 TADJ. Okay, and this is minus 0.51, so we have minus 0.51 TADK. So we can call this equation 3. Okay, all right guys, so we've done the analysis of all the forces, all the tensions acting on the cables that make up that holds the balloon. So the next thing to do is to sum them up. Summation of all tension forces. Okay, so if we do that, we'll obtain, all right, so summation of T equal to tension in cable AB plus tension in cable AC plus tension in cable AD. Similarly, it is also important for you to know that we said it was given earlier that there is a vertical force P acting at point A, which we included in our free body diagram. There is a force P, and we assume that this force is pointing upwards, so it's positive. Okay, it's also not wrong if you assume that this force is pointing downward. All right, so if we've collected the tensions in cable AB, tension in cable AC, and tensions in cable AD, also remember we'll assume there's a force pointing upwards here, P. Okay, some other person can assume this force is pointing downwards. It's not wrong. If it's pointing downwards, it means it's going to be minus PJ. So you take note of that. Alright, so we assume that force P is pointing upwards, so we simply indicate plus PJ. So these are all the forces acting on the balloon at point A. Alright, but for equilibrium, the summation of the tension force T is equal to what? 0. So it simply now implies that position vector of tension AB plus tension AC plus tension AD plus PJ is equal to 0. Mind you, if you assume that this force P is pointing downwards, it means you have to indicate minus PJ here. At the end of the day, you won't still be wrong. When you obtain a value for P, you will tell if it is positive or negative, if your direction is correct or wrong, depending on the answer you obtain. All right, so let's bring in all these terms. So we have to sum tension TAD. Tension TAD was gotten from equation 1. Okay, tension TAD give us from 1, so we have minus 155.4 I minus 207.2 J. Okay, so minus 155.4 I minus 207.2 J. This is tension in cable AB plus tension in cable AC happens to be the second equation 2. So we'll have this will be tension in cable AC. So let's add this up and see. Alright, so we add up tension in cable AC, and that's 0.30 ACI minus 0.76 TACJ plus 0.57 TACK. So plus, we'll now add up the tension in cable AD. Okay, I think that should be the last equation, which is this. So we'll have minus 0.860 TADJ. So we'll have minus 0.86 minus 0.86 TADJ minus 0.51 TADK. Okay, that's the tension in cable AD, then plus PJ. Alright, so plus PJ, and that's equal to 0. Okay, so all we did was TAB, which is this, plus TAC, which is this, plus TAD, which is this, plus PJ, and equal to 0. So we'll have this. Okay, so let's remove the brackets and write them out individually. Let's remove the brackets and see what we'll obtain. Okay, so we remove the brackets. Okay, we'll obtain this. All we did was to just remove the bracket and write everything we have here down. Okay, so I'm doing that. Let's collect like terms, okay, in unit vectors. Alright, so let's bring all the i's together and all the j's together. So we have minus 155.4i. Okay, let's bring all the i's together. We have 0.3 TACI plus 0.3 TACI. Okay, okay, I think that's all the i's we'll have, so we'll close the bracket. Okay, so we'll bring all the j's together. Let's bring all the j's together. We have minus 207.2j minus 207.2j. okay, we'll have minus 0.760 ACJ minus 0.760 ACJ. Okay, we also have minus 0.860 ADJ minus 0.860 ADJ. We also have PJ plus PJ plus PJ. Close the bracket. Okay, let's bring all the k's together. We'll have 0.570 ACK, 0.570 ACK. We have minus 0.51 ADK minus 0.51 ADK. Okay, and this is equal to 0. Alright, so next step, let's factor out the unit vectors. The ij and k. I might pause the video a bit to do that because the video is getting too long. From this position, we factor out all the unit vectors ijk in terms of ijk. So we'll have this. So we just factored out the unit vectors I. Okay, this is j and this is k. Okay, equal to 0. Alright, so now recall that when we talked about the analysis of 3 dimension, we said that f is simply fxi plus fyj plus fzk. Okay, we obtain this. So this simply now implies that okay, summation f, sorry, okay, is this. Okay, and we said summation f is 0, so it means that fxi plus fyj plus fzk is equal to 0. Okay, so if we compare these two equations, or we can as well write, it also implies that txi plus tyj plus tzk is equal to 0. So comparing this equation, call this equation 4, this equation 4, so call this equation 5. So comparing 4 and 5, equation 4 and 5, we have that, okay, it implies that txi is simply equal to what? This minus 155.4 plus 0.3 TAC. Okay, call this equation 6. Also, it means that tyj is equal to, okay, compare this in I. Okay, so tyj is equal to this in terms of j. So we have minus 207.2, okay, minus 0.760 AC minus 0.760 AC minus 0.5860 AD minus 0.860 AD plus P, okay, all into J. Okay, call this equation 7. Okay, so it also means tzk is equal to this in terms of k. So we'll have 0.570 AD, okay, minus 0.51 AD, sorry, TAC minus 0.51 TAD, okay, all into k equal to 0. So you can call this equation 8. Okay, so you have this. All right, so let's begin with 6. So from equation 6, we'll have that txi is equal to minus 155.4 plus 0.3 TAC all into I. Okay, so I can cancel I. We'll have that tx is equal to minus 155.4 plus 0.3 TAC. For static equilibrium, from static equilibrium law, Tx equal to 0. Okay, so we equate the whole equation to 0. So we'll have minus, so that simply implies that minus 155.4 plus 0.3 TAC is equal to 0. Okay, and from here, if we send minus 155.4 over here, negative changes to plus, so we'll have 0.3 TAC equal to 155.4, and therefore TAC is equal to 155.4 divided with 0.3. So that implies that tension in cable AC is equal to 518 newtons. All right. So from equation 2, we have Tyj equal to Tyj. Sorry, from equation 7, please. From equation 7, okay, so we have Tyj to be equal to minus 207.2 minus 207.2 minus 0.76 TAC, okay, minus 0.86 TAD minus 0.86 TAD plus PJ plus P all into J. Okay, J cancels J. All right, so we'll have Ty to be equal to minus 207.2 minus 0.76 TAC minus 0.86 TAD plus P equal to, okay, plus P. We have this, okay. All right, so we know the value of TAC. TAC is 518. So in place of TAC, Ty equal to minus 207.2 minus 0.76. In place of TAC, we'll have 518 minus 0.86 TAD plus P, okay. Ty equal to minus 207.2 minus 0.76 by 518. Okay, 393.68 minus 0.86 TAD plus P. Okay, from equilibrium law, okay, from equilibrium law, Ty is equal to 0. So we'll have minus 207.2 minus 393.68 minus 0.86 TAD plus P equal to 0. So let's evaluate this. Minus 207.2 minus 393.68. Okay, that gives us minus 600.88. Okay, minus 0.86 TAD plus P equal to 0. Let's call this equation 9. Let's call this equation 9. So from equation 8, we have TZK to be equal to 0.57 TAC, 570 AC, okay, plus 0.3 TAC, right, minus 0.51 TAD, minus 0.51 TAD, and that's L, okay, into K, all into K, okay. So K cancels K. We are now left with TZ to be equal to 0.57 TAC minus 0.51 TAD. All right, but TAC has a value, it's 518. All right, so TZ is equal to 0.57 into 518. In place of TAC, we put 518, okay, minus 0.51 TAC. All right, so TZ is equal to, expand this bracket, 0.57 by 0.518. We have 295.26 minus 0.51 TAC. But from equilibrium law, okay, TZ equals 0. Now that simply implies that 295.26 minus 0.51 TAC is equal to 0. Alright, so we send minus 0.51 over to this side of the equation. We'll have that 295.26 is now equal to 0.51 TAC. Okay. Alright guys, so sorry, this happens to be 0.51 TAD. Please take note, 0.51 TAD, not TAC. TAD, alright. It's a long calculation over there, you know. Alright, so to make TAD subject, we divide both sides by 0.51. So that simply implies that TAD is equal to 295.26 divided 0.51, and therefore TAD is equal to, we'll have 578.94 newtons. So we have tension in cable AD. Alright, so we have tension in cable AD, we have tension in cable AC. We can now substitute into equation 9 in place of TAD. Alright, so from equation 9, we had minus 600.88 minus 0.86 TAD plus P equal to 0. So in place of TAD, we'll simply put the value 578.94. Okay, so we'll have minus 600.88 minus 0.86, 578.94, okay, plus P equal to 0. Okay, minus 600.88 minus, we'll expand the bracket. Alright, so we'll have 497.89 plus P equal to 0. Alright, so we'll evaluate this to minus 600.88 minus 497.89. Alright, so that's minus 1098.77 plus P equal to 0. So we'll send minus 1098.77 over this side. Alright, so that simply implies that P is equal to 1098.77 newtons, and that's the value of P, guys. So it means the direction we assumed for P was correct. It means P was actually going upwards. Alright, thanks guys. That's a very long video out there. Thank you for that video. Like if you find it interesting, share to your friends. For more subscribers, I will see you in the next video on 3 dimension. Thank you.